Hi, everybody. Happy Friday. This is officially the latest time I've ever recorded a lesson video, so please notice the time. It is 10:56 p.m. That is because your math teacher has a ton of stuff in her classroom at school, and it has taken her probably a cumulative 10 hours to start packing up, and I'm still not even close to being done. Before we get started today, I just wanted to say thank you guys so much. Thank you to all the people that reached out to me about my foot. Yeah, it's been a hot mess, and so if you saw my video from the classroom before, then you saw my foot. If you don't know what I'm talking about, let me see if I can show you. Oh, oh my gosh. So it's kind of a hot mess, but I appreciate everybody reaching out to me. You guys are literally the sweetest kids in the whole world, and I love you forever for it. So thank you. Today's lesson, we are talking about analyzing scatter plots. Okay, so you actually have a lot of objectives for today, so just give yourself like a hot second before you take a look at them. Okay, so by the end of today's lesson, you will be able to draw a line of best fit, identify scatter plots with positive, negative, or no association, identify linear and nonlinear associations, and use scatter plots to make predictions about data. It is a lot, but you guys, I don't want to say it's like common sense stuff, but like once you kind of see the material, it's really not that hard. Okay. It seems like it's a lot, but you guys are also really smart. So you'll get it. I promise. Okay. So here we go. When we're looking at scatter plots, number one, what is a scatter plot? And number two, what is this scatter plot talking about? What is it comparing? Well, we know that a scatter plot is a graph that's used to obviously plot data points and compare two variables. This graph in particular is talking about height and arm span. You guys, we did this at the beginning of the year. We measured our height and then we compared our wingspan, and we compared the two. So this graph is talking about height and arm span. As you can see, as you get taller, you can tell that your arm span also typically increases, which makes sense. So if you think about like Miss Vanna, like think about how little she is and how like little her arms go wide, but think about somebody like me who's very tall. As my height gets larger, obviously it increases, my arm span, okay, is much larger. So scatter plots compare two variables. Okay, we got two sets of data here, and it's using data points to show that. So, what is a line of best fit? Okay, what is a line of best fit? When you're looking at a scatter plot, you will often see a line like this drawn that goes in the middle of data. A line of best fit is kind of used to show others, like what is the trend? What's happening with your data? Is it increasing? Is it decreasing? Is there a trend line? So we use lines of best fit to make predictions about data and also just to give yourself like a better picture of what it looks like. Your lines of best fit have to be in the middle of your data points. That means that about half of them are on top of the line and half are below. This would not be a good line of best fit. It's not even in your data set. This would not be a line of best fit. It's not even in your data set. But if you draw one like right in the middle of all your points, that is great. That's your line of best fit. It fits right in the middle of all of your points. So let's practice really quick. I'm going to move myself over so you can see. So you've got a scatter plot here and you've got a scatter plot here. I'm asking you just to draw a line of best fit. Now don't laugh at me, but I'm going to try and use my little arrows here. And you guys, I know it's all funny for me to take forever to use my computer. Okay. So when we're drawing the line of best fit, notice that it has to go in the middle of all of your data points so that you've got about half above, half below. Okay. And you can also kind of tell that we're looking at temperature and sales. If you were drawing a conclusion, you could say that as your temperature increases, your sales also increase. They're probably talking about ice cream. If you're looking at this graph here, notice that it's going down, so your line of best fit will also be going down. And notice I drew it just right in the middle of the data points. That's showing that the greatest fit for those data points is the orange line shown. All right, now what if we were looking at a graph like this? Is there a way that we can draw a line of best fit for this data? Okay, if you look at these two here, they're all kind of like in a line here, but for something like this, can you draw a line of best fit for that? And hopefully you can tell by my face and the way that I'm asking you the question, the answer is no. And that brings us to our next topic of our lesson today. So here we go. There are three types of associations when we're talking about scatter plots. There's positive, there's negative, and there's no association. Most of us can probably identify based on the way that the dots are going, like, oh, that's positive or that's negative, or there's no association there. But if you're ever not sure, you can draw in your line of best fit to kind of help you and look at the slope. So if we drew in our line of best fit here, notice that it's going up. Okay, so that'd be a positive slope. That means there's a positive association. Notice for your second graph that these are going down. Okay, and because those are going down and it has a negative slope, that means that it's a negative association. For this guy here, I can't really draw it going up or down because it just doesn't really make sense for the data set. That means that there's no association. If I'm looking back at these graphs here, because this is going up, that would be a positive association. This would also be a positive association. As your temperature is increasing, your sales are increasing. This guy, because it's going down, it would be a negative association. Hopefully you can kind of see that. You guys are awesome at slopes, so I don't think it'll be that hard. Okay, next topic. Now we can dive even deeper. We know that we can identify positive and negative and none. Now you can identify the strength of the association. Here's my quick tip for you. If your dots are very close together, it is strong. Okay, think about a family photo. If you've got your family members that are very close to you, like hugging arm in arm, that's usually like a close-knit family, like they're a strong family. Not always, but I'm just saying. If you have dots that are further apart, that would be a little bit weaker. Okay, so if you were thinking like if this was my family, like we're not very touchy-feely, like if we were taking a picture, it'd be like, okay, you go stand over there, I'll stand over here. That would be like a weaker association. Okay, we're not bound as tight, it's weaker. So look at these pictures right here. Because these are going up, okay, the dots are going up within your scatter plot, and let me draw the line for you. Not only is it positive, but they're also very close together. So that's a strong positive association. These dots are still going up. If you draw your line of best fit, they're still increasing, but notice that they're a little bit further apart. That's a weaker association. And then last right here, there's no way to tell if these dots are increasing or decreasing, so there's no association there. So you cannot draw a line of best fit, and you can't tell me, ooh, that's strong, that's weak. No, it's nothing. These guys down here, let's start with the strong one. I can tell that these are going down, and then there's my line of best fit. Those dots, the data points are very close together, so that's going to be a strong negative association. Negative because it's going down, strong because your dots are very close together. Now, these guys here, you can still see that they're going down, like that magenta line here would be my line of best fit, but they're a little bit further apart, so that would be weaker. Okay, this might be something you want to take a picture of or write it down in your notes. So not only can we tell that we've got positive, negative, and no association, but you can also tell me the strength of it, if it's strong or weak. Okay, strong, close together, weak, far apart. And now we can go one step further. Isn't learning close to midnight so fun? You can tell me if a data set is linear or nonlinear. You guys, we did this at the beginning of the year, specifically in Unit 3. Now you're just looking, does this make kind of a straight line or does it not? I don't know. So if we're looking at this data set here, do you see how this has a curve? Well, is that a straight line? No. So it's nonlinear. Okay, this would be a nonlinear scatter plot. These guys here, this pretty much forms a straight line. I mean, not exactly as a scatter plot, but this would be a linear scatter plot. This would be nonlinear. So now you know, okay, let's kind of bring it all together and sum it up. You know the type of association, okay, positive, negative, or none. You know the strength, if it's strong or weak. And you can tell me if it's linear or nonlinear. So let's practice that when you play your game later for your homework, you know what's going on. All right, so here we are. Taking a look at this graph, the first thing you want to do is drop in your line of best fit. So this would be about perfect because it goes about halfway through. So step one, what type of association is it? Is it going up, down, or is there no way to tell? Well, I can see that this is going up, so that's going to be a positive association. Are your data points close together and strong, or are they further apart and weak? Well, I see they're very close to this line. They are very close to that line. So that's a strong association. And it looks like it's in a straight line, so it's going to be linear. So not only is this a strong positive association, but it's linear too. All right, taking a look at this one. I see these points scattered everywhere. There is really no way for me to even drop in a line of best fit here, so that doesn't work. As soon as you cannot draw in a line of best fit, you know that's going to be no association. You can't tell me a strength because there's no line of best fit, and it's definitely nonlinear. Okay, there's no line there. All right, this one here. Is it a positive, negative, or no association? Let's draw in our line of best fit first so that we can see. Well, I know that that line is going down. It has a negative slope, so that's going to be a negative association. The data points are very close to the line. They're very close together, so that will be a strong correlation or association, and it also looks like it's in a straight line, so it's going to be linear. Now let's go even further. Now I'm starting to kind of expose you to some things that you're going to see in high school just because that's who I am and because I care about you and I want you to be awesome next year. All right, you can also use scatter plots to make predictions. So here's what I'm talking about. Looking at this graph, we are talking about the number of participants and the cost per person. That's like, how can I put this for you? Think about if you're buying t-shirts, okay, like you're on a sports team. If you buy 5 t-shirts, maybe it's $20 a shirt, but if you were to buy like 100 in bulk, the cost goes down. So in this graph here, as the number of participants increases, the cost per person goes down. Now, if I asked you to find or predict the cost for 50 people, find where 50 people or participants is right here, and you can kind of trace it up to where you think that dot would be. Do you see how it's kind of like right at about 900? So if I was making a prediction, I would say that that would be about $900. If I was asked to make a prediction for 180 people, I would go down here and find 180, and I feel like the point would be like about right here. So maybe that would be like about $20, $25. The main point being, you can use scatter plots to make predictions. It's never going to be perfect. It's never going to be accurate. But using lines of best fit and using the data that we have, we can make predictions for data that might not be there. Let's try again. This is going to come up on your homework later, so make sure you pay attention. This graph is talking about the study time in hours and your math grade as a percent. Notice like for 1 hour, this person got like a 62%. Versus close to 7 hours is closer to 100%. What do you notice about this graph? As you increase your study time in hours, notice that your math grade, your percent also increases. Guys, this is a positive association, and this is good for you to know for life. As you increase your study time, your grades also increase, especially for math. So if I was asking you, all right, make a prediction about your math grade at 6 hours. So here's where 6 hours is. So I'm going to trace this up. And I feel like the point would probably land about right here. So that means that if you were to study for 6 hours, you would probably get like around like maybe like a 93%. Around there, 93, 94%. What about for 7 hours? So I'm going to go where 7 hours is right here. And I'm going to trace that up to where all these data points are. If you studied for 7 hours, you'd probably get close to 100% or maybe 99%. So that's just using this, like the data to make predictions. Now, very last thing that I'm going to talk about, and then I'm done, I promise, is drawing conclusions from scatter plots. This is the most important skill probably that you could take away from this lesson in this whole unit. That means that you're looking at a graph and you're drawing a conclusion, you're making a statement from what you see. If I asked you to draw a conclusion from this graph, look at your 2 axes here. We're talking about study time in hours and math grade. What can you tell me? What's that broad statement that you can make about the data? Well, I know that as the number of hours that you study goes up or increases, your math grade as a percent also increases. So as study time goes up, your math grade goes up. How about this graph too? Oh, sorry. Give me 2 seconds. I messed up the slide. Just give me 2 seconds to fix it for you. Okay, I'm back. Sorry about that. Okay, so now take a look at this graph here. This graph is comparing the number of siblings that you have and your grade. Now, let's think about that right now. I have one brother. Does that one brother impact my grade in math or my grade in science? Or if you had 3 sisters, does that impact how well you do in math or social studies? Take a look at the data points. Do you see a positive association or a negative association or anything? No, you don't. That means that there is no association between the number of siblings you have and your grade. That would be like telling me like, "Oh, like what about the association with your shoe size and your number of friends?" Does the fact that I wear a 9.5 shoe affect how many friends that I have? No, and I do have friends, so calm down. Don't say in your head, well, Miss Levan, you don't have any friends. So there are going to be graphs where you don't see an association, which means that variables have no impact on one another. Okay, ladies and gentlemen, let's sum up what we learned today, and then I'm going to talk about your assignment. Today, you guys learned how to draw a line of best fit. Okay, that's when you've got a scatter plot here with points and you draw a line that goes halfway through all of them. Okay, that's a line of best fit or a trend line. You learned how to identify the association, which means positive, negative, or none. The strength, meaning that the dots are close to your line, they're strong or they're weak, they're far apart. And you learn how to tell if a scatter plot is linear or nonlinear. You also learned how to make predictions about data based on a scatter plot. That's what we did here, okay? When we found our line here, we found our number, we traced it up, and we made a prediction. It wasn't exact, it was a prediction. And lastly, you learned how to draw conclusions from scatter plots. So you told me like, as the number of hours increases, your grade increases, or there is no association between the grade and the number of siblings. If we were looking at a negative graph, we were looking at here, this is like when we say as the number of participants increases, the cost decreases. So you guys learned a lot today and wonderful job. Okay, as always, your assignment for today is the Analyzing Scatterplots quizzes. I put the code in your update, so if you want to just copy that over and follow the link, it's also in the e-learning folder. I love you all very much. Have a wonderful weekend. If you get bored, message me. I always love to hear from you. And yeah, that's it. Thank you guys. See ya.